The way the way the way I like to think about non-experimental designs or the different designs is by considering two approaches or two paradigms. The first paradigm is how I go about selecting the participants. The second paradigm is about time, assessing time. And what I mean by time is I mean exposure and outcome. So let's think about this first. Um, I think it's pretty obvious that exposure comes first and then outcome. If you go about collecting your data following this order of things, meaning that you start with exposure and then you wait for outcome to occur, then this is what is called a prospective design. You start up with people with exposure and people without exposure, and then with sufficient time passing, some people start getting the outcome and some people don't. But and therefore it's a perspective. There's a time process and you're actually doing some sort of a follow-up of your participant over time. And this is a prospective design. If you actually address the outcome and exposure in the reverse order, so you start up with your outcome, and after you found people that have the outcome or people that do not have the outcome, then you went out to try to assess their exposure that happened in the past. Therefore, you're approaching the issue in the reverse order. Then this is a retrospective design because you're going retrospectively. You're going back in time, or back in the order of things. You're starting with the outcome and then you're looking at the exposure. The last approach is if you look at things concurrently. So now, who's got the outcome and who doesn't get who doesn't have the outcome, and who is exposed and who's not exposed now at this time point. Then this is a cross-sectional, a concurrent type of designs. And therefore, out of these three approach, you have three different designs. And these designs are the cohort, the case control, and the cross-sectional. So I'm going to talk about each one of them, and every time I'm going to explain how you can think about this design in terms of how you got your participants and in terms about the time approach. And again, time, I mean, do you start with the exposure and then you wait for the outcome, or you start with the outcome and then look for the exposure? All right, so the first design we have to here is called the cohort design. And cohort comes from, I think it's a Roman thing where you had legions and army. They created cohorts where they fight together. And anyway, so what is a cohort? A cohort is a group of people that you're going to follow up in time. And these group of people, at the beginning of the study, they all should be free of the disease. And you're going to look at those people as whether or not they have or they do not have the exposure. After that, after you ascertain their exposure status, no one has the outcome. You're going to follow them up till the outcomes start occurring in the exposed group and the non-exposed group. Therefore, it's a prospective design because your starting point is the exposure, which is the right, is what comes first. And then over time, you're going to look for the outcome, and therefore it's a prospective design. Now, if you want to think about it, how you selected your participants, well, if you think about it, your starting point are those that actually are exposed or not exposed. Therefore, your selection is based on the exposure. Your selection is based on the independent variable. So you select your participants on whether or not they have the exposure, and then you follow them up in time till they start having their outcome. So example, very simple example is I start up with people that are exposed to, let's say, obesity, and people that are not exposed to obesity. At time zero, at time where I'm recruiting my participants, no one should have, let's say, a cardiac outcome. And then I start follow these people over time, over maybe 1, 2, 3, 4, 5 years. And as I'm following them up, some of them will start having cardiac problems, cardiac outcomes, and therefore I'm start to seeing outcome. This is a cohort, okay, because it's a perspective, because I started up with exposure and then I followed up till the outcome. or because I started up, the selection is based on whether or not they're exposed, not whether or not they have the outcome. In fact, no one should have the outcome at the beginning of the study. So cohort, as I said, is a prospective, is longitudinal in time. However, there are two types of cohorts. Both of them are prospective, both of them are longitudinal, both of them start with exposure, and then they look at the outcome after some time have passed. The difference between the two is one is exactly as I explained. So let's say you start your study in 2019, you will do the follow-up till 2020. Then this is called a concurrent. It follows people in real time. Versus a non-concurrent is a cohort that already occurred in the past. For some reason, somebody already did this work for you, already collected the data for you. And now in present, so in 2019, you're coming now and you're analyzing the data. So why would somebody collect data for you that is suitable for a cohort? Well, obviously they're not actually doing a cohort. They collected this data for reasons that relate, for example, to the kind of work these people are doing. So let's say you look at, let's say, insurance companies. Well, these insurance companies, they might have information on their subscribers, and if somebody is down with a certain, let's say, hypertension, well, it will show on their insurance company cards. And if at a later point in life, after 6, 7, 15, 20 years, these people develop, let's say, a certain cardiac arrest, well, it will show again on their insurance company paper because they're actually paying for them. Therefore, though the insurance company is not collecting the data for a purpose of a cohort study, but actually they are collecting the data, and this data is available, you can come and use the insurance company data and build a cohort that already has been done, but you will use the data that you need for the purpose that you want. So therefore, I would go, for example, for my insurance company, and I'll tell the computer person there that go back in your records for the years between 1990 and 1995. In these 5 years, please get me a group of people that had hypertension, and I need also a group of people that do not have hypertension between these 5 years. And I make sure that none of those that I selected that have hypertension actually had a cardiac arrest. And therefore, I tell the computer person, now that we selected our cohorts between 1990 and 1995, none of them having cardiac outcome, but a group is having hypertension and a group is not, please check for me who at a subsequent time, yani after 1995, developed cardiac arrest and who did not. And therefore, it's like follow up these people in the right order of event, yani exposure, then outcome, but all of that already happened in the past. Therefore, you're looking at what we call non-concurrent cohort, non-concurrent prospective cohort. And basically that's it. That's the basic difference between the two. So up here I'm showing you the concurrent cohort where the present time is here. You put people in either expose or not, and you start following them up in real time till the outcome occurs. Versus a non-concurrent cohort is where present time is here, but on records you're going to go back in time, identify the exposed and the not exposed, make sure no one has the outcome when you identify the exposure, do a follow-up on virtual time on records, and find those that will subsequently develop the disease. All of this is based on records that have already been collected. Okay? Now, as I said, one is called prospective cohort concurrent. The second one is called prospective cohort non-concurrent. A word of caution. In the literature, you will find people that call prospective cohort non-concurrent. They will call them retrospective cohort. Now, this is, according to us in this class, this is wrong. But this happens a lot. Even in the literature, you'll find people publishing non-concurrent cohort as retrospective. For us, we're going to call prospective and retrospective in relation to the exposure and the outcome. So if you look at the exposure first, then you look at the outcome, therefore you're looking at things in the right order, it will be a prospective study. If you look at things in their reverse order, meaning you start with the outcome and then you look at exposure, then it will be a retrospective study. The way I defined non-concurrent cohort, they are prospective because even though everything had happened in the past, your starting point is the exposure, and then you start looking out for the outcome. Therefore, they are prospective, non-concurrent. Now, what are the advantages of cohort studies? They can establish temporality, meaning you can establish what occurred first, the exposure, then the outcome. You can aggregate, you can collect a lot of good information that are helpful for cause-effect relationship. And since you're starting up, no one has the outcome, and you're doing a follow-up of people that are either exposed or not, you can look at the number of outcomes. You're not limited to only one outcome. So let's say again you're looking at obesity and you're doing a follow-up. You could look at multiple outcomes such as cardiac outcome, diabetes, hypertension, depression. So only one exposure, which is obesity in this case, and multiple outcomes. Now, cohort has a number of disadvantages. Obviously, it's time consuming, especially if you're doing a concurrent one where you're following people in real time. It's expensive because you're going to require a lot of measurement. You're going to require a lot of uh, human resources and financial resources, so it's going to cost you a lot of money. And typically, it requires a large sample size, which also is going to add on your dollar bill. All right, so this is a cohort study, again, that we call concurrent, prospective. Well, what about the retrospective? What about the design where you're going to look at things in the reverse order? You're going to start with those that actually have the outcome and those that do not have the outcome. So typically those that have the outcome, we call them the cases. And those that do not have the outcome, we call them the controls. So you start looking for people that have a certain disease. Let's say maybe you're going to look for people that have a certain type of cancer. And you look at people that do not have this type of cancer. And then you ask them about their past exposure. Have you ever been exposed to, let's say, chemicals? Have you ever been exposed to asbestos, for example? Okay. Now, because you looked at things in the reverse order, meaning your starting point is the outcome, and then you started assessing the exposure, as we said previously, this is going to be considered a retrospective design. Again, if you think about it, about how you're recruiting your participants, now notice here, your recruitment, you're finding your participants based on the outcome, based on the dependent variable, and not based on the independent variable, which was the case for the cohort design. Here, you're looking at those of people, whether or not they have the outcome. So at the selection, you're not asking questions about exposure. At selection, all you're worried about is if a certain person has the outcome or does not have the outcome. That's all you are interested in. After you selected, then you start asking questions about exposure. And therefore, as we said, this is going to be considered a retrospective design, and therefore case control designs are retrospective. So this is the present. You're going to find people that have the disease or do not have the disease, yani cases, controls, and then you start to ascertain their exposure in the past. Now, typically ascertainment of exposure is going to be by questions. You're going to ask them a series of questions about what happened in their life and what they do in their life. Where did they work? Where did they live? Were they present when a certain event happened, etc. Sometimes you're lucky enough that you can actually measure their exposure by blood samples or by taking tissue samples, but this is not the typical case control design. So as we said, case control designs are retrospective. Why do we use them, or what are their advantages? Well, they're relatively easy to do compared to cohorts. They save you time and money. Obviously, you don't have to do the long years of follow-up. They're good when you're studying rare disease. So when you have a rare disease, if you were to do a cohort, you'd have to start with a very large cohort, and you'd have to probably wait many years for the rare outcomes to start popping out and showing. Versus if you do a case control, then all you need is to find those that already had the outcome, find another group that doesn't have the outcome, and ask questions about exposure. And therefore, it solves the problem of rare disease studies. Now, it has an advantage that is the total opposite of that of the cohort, where you only have one outcome, but you can ask questions about as many exposures as you want. So let's say you're studying a disease that has to do with liver cirrhosis. So you have to find patients that have the disease, the liver cirrhosis, and have a group that do not have liver cirrhosis. And then you can start asking them questions about like maybe their consumption of alcohol, maybe their family history, maybe about if they ever been exposed to some sort of chemicals, maybe if they are exposed to fumes. So many exposure, one outcome. Whereas if you remember when we were talking about cohorts, it was one exposure, multiple outcome. Here it's the reverse. Now, case controls have disadvantages. The most obvious one is that you cannot establish temporality, which directly impact causality. You cannot talk about causality. Uh, Case control studies are known to suffer from some certain biases. The two major biases that affect case control studies are recall bias and selection bias. Now, what is a recall bias? Recall bias is a bias that occurs when a group of people remembers their exposure better than another group of people. And typically, these are the ones that actually have the outcome. And this comes from the literature in a study when they were looking at women that have had children with birth defects versus women that had normal children. So the cases are women that had children with birth defects, and the controls are women that had normal children. And they wanted to ask them questions about if they were taking certain drugs during their pregnancy. While women that had the children with birth defects, because maybe of guilt, they remembered with very specific details about their pregnancy and what kind of medications or drugs and exposure they had. So their memory was much stronger than women that had a normal baby, because the woman that had a normal baby had no reason to remember strongly what she was doing during her pregnancy. Therefore, you might end up with a difference between the two groups that is not due to a real difference, rather than a difference in remembering. So that's recall bias. Selection bias is basically when those that you end up selecting to be in your study are systematically different than those that do not take part of your study. And a very simple example for that is when you're doing a case control study, obviously the cases that you are recruiting are cases that are still alive versus cases that died. You cannot recruit in your study if you're going to do an interview. Well, can we consider cases that are still alive similar to the cases that died? Many times no, because cases that died may have had a worse prognosis, which might be impacted by their different level of exposure, and therefore you're going to end up with a biased association. So recall bias, selection bias are major disadvantages for case control studies. Confounders, that is, as we discussed before, is a type of variable that alters the relationship between the exposure and the outcome. And in a case control study, you cannot control confounders easily. Versus in other types of study, the cohort study, you have ways to control the confounder much better than in a case control study. So the third type of study design, observational study design, is where your selection process is irrespective of whether the person is exposed or not, like in the cohort, and irrespective of if the person has the outcome or not, like in the case control. So when you select participants, you select them regardless of their exposure status and their outcome status. After you selected them, you're going to ascertain, or you're going to assess their exposure and their outcome at the current time. And therefore, it's called a cross-sectional. It's a concurrent type of studies. And if you think about it time-wise, this is where you're looking at exposure and outcome at the same time. It's like you're taking a snapshot of what is happening now. You're not doing it in the future, you're not doing it in the past, you're just looking at things now. The most widely used cross-sectional studies are the surveys. They are typically used to get information about people's characteristics at a given point in time. They could be good, for example, to look at what is the prevalence or what is the proportion of the population that are, for example, smoking, or what is the proportion of the population, the prevalence of the population that are exercising, that currently have heart disease, currently have diabetes, etc. Obviously, it's not a very good study design to look at cause-effect relationship because you're not considering the temporal relationship between the exposure and the outcome, the independent and the dependent. All you're seeing is that you may have people that currently have the disease, currently they may have hypertension, but also they could be currently are exercising. Well, it doesn't mean that exercise is causing hypertension. It could be just because of the fact that they have hypertension, they started exercising. But not to downsize cross-sectional studies. Cross-sectional studies are important. They can provide a lot of information, and you can learn a lot of things from cross-sectional studies. Now, non-experimental designs in general have advantages. They can address research questions that could not be otherwise addressed. Large data of information is collected, and researcher can look at a number of phenomena and see how they are interlinked. And these non-experimental designs are realistic. طبعا compared to experimental designs, where we said that in experimental design you have, if you remember, we talked about uh, the internal validity and the external validity. And we said that experimental designs, typically they have very good internal validity because you're putting a lot of constraints and you're controlling a lot of factors, and therefore your study becomes very powerful in terms of its internal validity, but it loses on its external validity. Versus observational studies, you're letting things happen the way they happen in real life, and therefore these studies are realistic and they have external validity. Some example of observational studies. This is an example where 592 patients of bladder cancer were selected, and they were controlled with 536 people that do not have the cancer. So if you think about it, the process of selecting these people into the study is based on whether or not they had bladder cancer. So whether or not they had the outcome. So obviously this is a case control design. After they collected the 500 so people cases of bladder cancer and the 500 and so controls, well, they asked them about their history of consumption of artificial sweetener. So they asked them question like, are you an avid user of artificial sweetener? How much do you use it per day? What do you use it, and how long have you been using it? And well, in this study, they found out that there were no difference between the group. But what I care for in this example is you should be able to realize that this is a case control study just because of the selection process. Ask yourself, how did they select the participants? And in this example, they select them based on whether or not they had the outcome. Here, the outcome being bladder cancer, and the exposure being artificial sweetener. Another example, this is a nurse's health study. We kind of addressed that, or we mentioned the study before. The nurse's health study enrolled about 120,000 married female nurses, and they were classified as either users of oral contraceptives or not. And then they followed them for 2 years. And during the follow-up, they were looking at things like cancer and cardiovascular diseases. And the question is, what do you think this design is? Well, think about it. The way they recruited their participants in the study is based on whether or not they are using oral contraceptives. Therefore, based on their exposure status. And then you may notice that there is a follow-up period typical of the prospective design. And during the follow-up, they started looking at whether the certain outcomes starting to occur, cancer, cardiovascular diseases. Also, all of this is typical of prospective design. So this is a cohort study. The exposure is oral contraceptives, and the outcomes, with a plural, is cancer and or cardiovascular diseases. This is called a pyramid of the clinical evidence, and you have a variety of these on the internet. There are many, many, many out there. What is important is you should know if you were compare different designs, which ones are stronger in terms of the type of evidence they provide. If you remember at the beginning of the lecture about experimental design, I started off with the case report and case series, which are not experimental design, and they're not even at the level of analytical studies. You don't have a control group. Well, these come at the bottom of the pyramid. They don't allow you to test a hypothesis. They may generate idea, they may generate hypothesis, but you cannot really answer a question, and therefore, evidence-wise, they're weak. The second, that the designs that comes on top of these are the observational designs, and on the top of the observational designs, you have the experimental designs. Now, within observational designs, the weakest are the cross-sectional, followed by a little bit stronger are the case control, and the strongest observational design are the cohort studies. Then we move into the experimental design, and obviously the strongest experimental design are the randomized control trials. We can start adding randomized double-blind, etc. But in general, RCT are the stronger single designs. If you start pulling experimental designs together and doing a meta-analysis or systematic review, then you have even a higher up level of evidence. So again, this is just one example of the pyramid of evidence. There are many different variety of that pyramid. Use whichever one you feel comfortable with, as long as you follow the ordering that I just presented. I have a few slides on meta-analysis, but I'm not going to discuss here, and I don't think you're going to be responsible for anyway. All right, so this concludes lecture 2, observational designs.